Okay, so in the previous lesson we talked about limits at infinity. And I asked you guys to look for patterns, but I never told you in the end what the patterns were, so I'm going to do that this lesson. Okay, so in the first case, you saw that if the degree of the numerator equaled the degree of the denominator, then the limit as x approaches infinity, what did it come out to be? It came out to be the ratio of the leading coefficients. Sorry about my messing writing there. Coefficients. Okay. So it came out to be that ratio. Now, degree, by degree, I mean the largest power. So if the largest power in the numerator is equal to the largest power in the denominator, then as we approach infinity, the answer is going to be the ratio of the leading coefficients. So in the previous lesson we saw both the top and the bottom had a degree of 2, and therefore the answer was the ratio of 5/3. Okay, that's the first case. In the second case, if the degree of the numerator is smaller than the degree of the denominator, okay, then the limit as x approaches infinity is going to be what? Well, it's going to be 0. So let's think about this. That means that the denominator has a larger degree than the numerator. So we can think of this as a race between the numerator and the denominator. So as x approaches infinity, both the top and the bottom are going to both go to infinity, but in this case, because the bottom has a larger degree, right, it's being raised to a larger number. So because the bottom has a larger degree, it's going to approach infinity faster. So it's going to beat the numerator in a race to infinity. Okay. They both approach infinity, but the bottom does it faster, because it has a larger degree. And therefore, because the bottom goes to infinity faster, that means that the bottom is going to be larger than the top. And therefore, as the bottom goes to infinity, we know that the fraction goes to 0. So that's why this is so. And in the third case, so if the degree of the numerator was larger than the degree of the denominator, the limit as x approaches infinity is infinity, right? So in this race, the numerator has a higher degree, therefore it's going to approach infinity faster than the bottom. Therefore the end result is infinity over something, so it's going to be infinity. So think of it as a race, and when the top and the bottom both have the same degree, then what matters now is the leading coefficients. Okay, because both of them, we can think of this as they're both approaching infinity at the same speed. But now what matters is the leading coefficients that determines the speed. Okay, so let me show you an example here. So the limit of x minus x to the 4th plus x cubed over x cubed minus x plus 1 plus 2x to the 4th. Okay, now this is annoying. This is an annoying trick that some test takers use. It's just annoying. Right, so in this case, they purposely give you the exponents in the wrong order. So instead of starting from the largest to the smallest, they mix it up. Right, so make sure when doing these when you're taking these tests to look at all the terms. So here we see that the largest term is 4. Here we see that the largest term is 4. Since the numerator and the denominator have the same degrees, the answer is going to be the ratio of the leading coefficients. Now, the leading coefficients are the coefficients of the largest term, because this could be -1 over 2. And that's your answer. Okay, so one more thing. What about negative infinity? So if x approaches negative infinity, does our answer here, do the rules here still work? The answer is yes, all except for one. So let's think about this. If the degree of the numerator is equal to the degree of the denominator, does it matter if we approach negative infinity or positive infinity? No. Let's take a look here. Here we see that everything else is going to not be important as we approach infinity. So only the largest terms will be important. So what happens is that we, in this case, well, it's an even power. So anything to the even power is going to be positive. Right? So let's say we have something else. Say, 3 times x cubed all over x cubed plus 1. Negative infinity. Okay, so this term is not going to be important, so what's important is this. And the top is going to go to negative infinity. The bottom is also going to go to negative infinity. So we have negative over negative, which is going to be positive. So the answer is just 3, right? It's still the ratio of the leading coefficients. So this thing does not change. It's still the ratio of the leading coefficients. What about this case? If the degree of the numerator is smaller than the degree of the denominator, well then, what's going to happen is that the bottom is either going to approach negative infinity or positive infinity. And we've seen that that doesn't matter, right? The answer is still going to be 0. It's just a question of, are we going to approach 0 from the top, from the positive side of the number line, or from the negative side of the number line? But the end limit is still 0. Okay, in this case it's going to matter though. So if the degree of the numerator is greater than the degree of the denominator, then as x approaches 0, okay, it's going to depend on the largest power of the numerator. So if it's even, right, so if the degree of the numerator is even, then it's going to approach positive infinity, right? And if it's odd, that means if you have an odd number of negative numbers multiplied together, so it's going to approach negative infinity. Oh, you can see that. Okay, there you go. Okay, so that's the summary. So just keep in mind to rearrange these terms if they're in the wrong order. Right, see you later.